So this is a series of questions and activities focused around 2.4, Earth's resources. You will have most probably used this in class or had a look at it. Here's a knowledge organiser kind of explaining all the different bits of the Earth and different things that we're going to be focusing on throughout this topic. Some nice, chronology glossaries that you can use. Again, you can kind of pause if you need to. Like I've spoke about in different versions of this, these are core knowledge questions. Core knowledge is really important for you to focus on, but I'm not going to explain each one in detail, but please take some time to kind of pause and have a look. Remember that this does focus a little bit on the water side of it. It fits in with this topic. So there are some questions around water, not just the Earth, and remember that they do get progressively harder as you go down the group, but please pause, take some time, have a look through them. Exactly the same for this review sheet, so please pause, have a look, have a think. So it starts off looking at like reusing water, public water supply, fluoridation of water. Then it kind of moves on to evolution of the atmosphere and different parts of the Earth. So, nice easy question to get started. State two pieces of evidence that Alfred Wegener used to support his theory. Similar rocks and rock patterns on separate continents. Similar fossil patterns on separate continents. Continents fit together like a jigsaw. Explain why Wegener was not originally accepted. He could not explain how the continents move. How do we explain that now? We use convection currents in the mantle to explain how the crust moves. Destructive events likely happen at conservative plate boundaries. Conservative plate boundaries are the ones where they rub against each other, so I think that would be earthquakes. Then looking at decayed, missing and filled teeth. This is an alright question because they've given you a graph and information to read through. Use the information in the table to explain why it's recommended terms, why there is a recommended term of DMF and fluoridosis. So we need to have fluoride in water or in toothpaste because it limits the amount of decayed, missing and filled teeth. However, fluoridosis is something that can be caused, and the higher the amount of fluoride in water, the higher the chance. So they pick a mean value that will make sure that both of them things are kept in check. Why is chloride added to water in everywhere in the UK, whereas fluoride is only added to some? Fluoride is seen as a kind of mass medication, whereas adding chlorine kills bacteria. It doesn't affect human health. It's got nothing to do with our teeth. Cleaning water now, what's the purpose of each of these things? So sedimentation removes large insoluble pieces, filtration removes small insoluble pieces, chlorination kills bacteria. Drinking water can be obtained by desalination. What is meant by desalination is how we remove salt from water. It's very important because a lot of the Earth's water has got salt in it, so we can remove it via reverse osmosis, which is basically pushing all the salt out. This then is a little kind of like question around separating sand and salt. Okay, so sand we know doesn't dissolve, so that's easy, we can filter it out, whereas salt is going to require some sort of evaporation of the water, which is what they're asking you to do here, is put these in order. So A, add water to the sample, stir, heat the solution, filter the mixture to get rid of the sand, then heat it, and then that will get rid of the salt. This then is a question about chromatography. Two mistakes. You can see how I've underlined them. We use a pencil so that the pen doesn't run as well, and then it must be below the sample for the water to travel up. Then there is a little diagram of the chromatography, and it says calculate the RF value for pigment 2. So you use the solvent front, how far the solvent's travelled, which is 10, divided by how far the pigment's travelled, which would be 7. Put that in the calculator. Remember that number has to be below 0. So if you don't get below 0, something's gone wrong. Looking at the atmosphere, nice easy question here for 3 marks. 3 ways that the atmosphere has changed. So there's no sulfur dioxide or no acknowledgeable sulfur. There is a little bit, but no acknowledgeable sulfur dioxide in today's atmosphere. Lower CO2 levels definitely in today's atmosphere, and higher nitrogen levels in today's atmosphere. Then looking at volcanoes, how have they helped change the Earth's atmosphere? They emit water to form oceans, produces CO2, which is absorbed from the plants for photosynthesis. So they're two different things they do. They also, which I didn't mention in the answer, but you could, is they do put a lot of nitrogen into the atmosphere as well. Looking now at the bigger process of what we would call the carbon cycle, but what they would call the carbon cycle, and looking at that. So two processes that emit carbon dioxide into the atmosphere: factory emissions and respiration. Name the process that removes carbon dioxide away from the atmosphere: photosynthesis. During the past 200 years, the amount of carbon dioxide in the atmosphere has been steadily rising. One factor that contributes to this is the increased travel to work. Other factors that carbon dioxide is levelled: deforestation, more fossil fuels needed to make electricity because we're more likely to use electricity. What do we call this? Global warming. 100 people travel 40k in the car, 1.6 tonnes of carbon dioxide travelling by the car, and there's different answers here. The amount of carbon dioxide produced when 100 people travel to work 40k. So just 1.6. Then you take away from the 1.6 the 0.2 if some people are travelling by coach. Would it be better for the environment if they made their journey by train? No, train emits more than the coaches.